time. Yeah. Now this here we doing past paper set theory questions, right? Now this here we are seeing is a Venn diagram, of course, and these questions here are will come often where they will give you a Venn diagram. They will give you a shaded portion of the Venn diagram, and they will ask you something about it, right? Now, this shaded portion here, you are supposed to, and I even read the question yet, by the way, but I see that there is a set P, it have a set Q, and this shaded portion here, you are supposed to recognize is the set P intersect Q. So that is what that is. This is the intersection of P and Q, where they say P are the factors of 6 and Q are the factors of 4. So what are the factors of 6? So P is the set of, and if you all could help me here, the factors of 6. Oh, look, my boy Mashaila done do it there, right? The factors, no, oh, careful Mashaila, right? Because you talking about multiples. I talking about factors, right? Oh, sorry. let's keep forgetting, right? So careful. We you talking about multiples. We talking about factors, right? Factors are the smaller ones. So the factors of 6 are 1, 2, 3. Yeah, these are the factors of 6. 1, 2, 3, and not 4, not 5, and 6. So these are the factors of 6, which is P, and Q are the factors of 4, which would be 1 and 2 and 4. So you can see, Mashaila, how you was mixing up factors and multiples. That is a common mistake that everybody does make. Plenty people does make that mistake. You will not believe how much. Even I myself used to make that mistake when I was a kid, right? When you see the word factors, you're looking for the big, no, these are the multiples. The multiples are the bigger ones. The factors are the smaller ones, right? Just remember that. So I could see here that they do intersect. These guys here are what they have in common. So P would have 1, 2, 3, and 6, and Q would have 1, 2, and 4. And the intersection, the shaded region represents the intersection, which is B, right? Just 1 and 2. Anybody have any questions? Please just feel free to interrupt me in the middle of my talking. There's no problem, right? A class of 32 students, 17 study music. Now 32 seems like some kind of a total day, right? 17 study music and 20 study art. So for music, I have 17. And for art, I have 20. But if you notice, 20 plus 17, that is 37. Yeah? That is 37. So what is the least number of students who study both music and art? Both music and art. So the thing is that this here is actually a set theory question. A lot of people do recognize as a set theory question, right? But you could use set theory to work this out, because you're talking about what is the least number of students who study both music and art, right? Because when we have add up the music students and we add up the art students, we get in 37, which is more than 32. So we can't just add them up, So what actually going on here is that we have the set of music students and we have the set of art students. And it have these ones in the middle here who doing music and art. So the ones in the middle here who doing music and art, we call them X, right? Then you have this here, the music people. Well, we know the music people is 17 in total. right? So that means that the people who doing music alone will be the total 17 minus the amount of X people that doing music and art. So X is the amount of people who doing music and art. 17 minus X is the amount of people who doing music alone. That is the total amount of people who doing music minus the ones that doing art. And of course, you can guess it by now. Over here, we'll have the art being the total amount of people who doing art is 20. And the people who doing art alone is 20 minus the amount of people who doing music. So now I have these three numbers here. These are the music alone. These are the music and art. And this is art alone. If I add these three up, right? So 17 minus X plus 20 minus X, I should get 32. 32, if I add these three up, I should get 32 students, right? So you see how this would have been a tricky question, especially if you didn't recognize that this is a set theory question involving algebra, right? So this is how algebra does jump into your set theory now. And so I could see that this plus X and this minus X gone. So I'll have 20 plus 17, which is 37, minus X is 32. And so if I throw this X across and throw this 32 across, I'll get 37 minus 32 is X. And so X will be 5. B. Right? The least amount of students doing both music and art is 5. So you have 5 students doing music and art in the middle day. 5 students. On to some easier ones here. We have the set P is this set here, 2, 3, 5, 7. The set Q is 2, 3, 6. And noticing that, you know, both of them have 2 and 3, so it have an intersection going on there. And the set S is 2, 4, 5. Then they want to know what is P intersect Q intersect S. That is, I noticed that these two have an intersection. P and Q have 2 and 3 in it. 2 and 3 in both P and Q. But look, S also have 2. So they want to know, where do all 3 of them intersect? The answer is A. Right? This is the element in all 3 of them. Now, you are supposed to know this without working out a Venn diagram. But just for the sake of explanation, a Venn diagram would look like this. This is P, right? This will be Q. This will be S, right? And you could see that I have the 2 in this region here with S, P, and Q. Right? So this 2 is in all 3 circles. Yeah. And so the Venn diagram would look like this. You have 2 and then you would have 3 here. So you notice the 2 and the 3 are in both P and Q, just like what this says, right? And then so P would have 2, 3, 5. Oh no, look, 5. 5 is in P and 5 is also in S. Check that out. So 5 is in P and S, so 5 will be here, right? 5 will be in P and 5 is in S, right? Understanding how to draw these Venn diagrams are super important. Yeah. Then what do we have here? Nobody else intersecting anywhere. So P will have 7 in it, Q will have 6 in it, and S will have 4 in it over here. This is what the Venn diagram for this question would look like, even though you weren't asked to draw it, right? Right. Now this here is a question that you all will have to get familiar with, and that is when they give you a Venn diagram that is shaded, and they ask you Well, which one of these here, this is set notation, represents the shaded region? Yeah. And well, I could easily see here, right? And what I'll do is I'll actually draw, just for the sake of further understanding, because we're going in deeper with these questions, right? So I will actually draw the Venn diagram for each one of these, and we'll see. But the answer here is A, P complement, because we could see what is shaded is everything outside of P is shaded. And so that's what complement is. A complement is everything outside. P complement is everything outside of P. But let me do the others. So B here, we have a brackets first of all, right? And if you look at the first set of questions, you'll get used to seeing those brackets. P union Q. So I have P union Q inside the brackets, and then outside the brackets have a complement. So what will that look like on a Venn diagram if you had to draw it, right? So I'll just draw the blank Venn diagram here, and this is P, and this is Q. And if you notice, what do they say? P union Q. So what is P union Q? It is the union of P and Q. So this here is P union Q. Everything in P and Q all together. But then the complement now says that they want everything outside of that. So everything outside of P and Q together. So you have to be able to look at these set notations and be able to come up with the Venn diagram for it. So this is what P union Q complement would look like. Let me look at C, which is Q union P complement. Notice no brackets. Notice no brackets. So I'm gonna draw my blank Venn diagram here. This is the universal set. This is the set P. And this is the set Q. And so check this out. Q union. So Q is this one. Q is this one. And I want that union with everything outside of P, right? So everything outside of P in union with everything inside of Q would be this. And even though that is inside of P, I am taking everything outside of P and I am joining it. Union is to join. So I am taking everything outside of P, but I am also joining it with everything inside of Q. And Q does include part of P. Yeah. So this is what Q union P complement will look like. And notice if I had left out, if I had made the mistake of leaving out the intersection, thinking, well, the intersection is part of P, I don't want that, you know, then if I had left out the intersection, I would have just have this. And then the last one here is Q intersect P complement. So I'll draw my diagram here. And this here is P. This here is Q. And so what do I want? I want the Q, I take in Q, which is this set here. This is the set Q. And P complement is everything outside of P. And so I want where those two intersect. and those two would intersect right here. This section here contains Q as well, all of the things in Q, but also all of the things outside of P, right? This is all of the things outside of P, and what they have in common, I should say that. All of the things outside of P, and then all of the things in Q, this is the section that they have in common. This section here, all of the things outside of P, and all of the things inside of Q, this is the section that they both have in common. That is what an intersect is. So this is Q intersect P complement. Look, we have another question here, just like the algebra one. So let's see. A group of students, 40 students, so that's a total that I have data with, right? 28 play tennis and 22 play chess. So I have the tennis group here, which is 28 in total. Ooh, again, some different answers here now. I like it. And then I have the chess people, who are 22 in total. And if I add 28 and 22, I'll definitely gain more than 40. So what is the least number of students who play both tennis and chess? Well, I will say that X amount of students will play tennis and chess. So X amount of students playing both tennis and chess. And so that means that the amount of students playing tennis only will be the total 28 minus the X. And then the amount of students playing chess only will be the total 22 minus the X. And so what I'll be left with is the total amount of students, which is this plus this plus this. So that is 28 minus X plus X plus 22 minus X. And that will add up to my total of 40 students. I could see this X and this X will go because of the associative law. And so now we have here 28 minus X. All right, 28 plus 22. 28 plus 22 is 50. Right, so that's 50 minus X is 40. If I throw this 40 across and I throw this X across, I'll get X is equal to 50 minus 40, which is 10B, right? Given that P is 2, 3, 5, 6, and Q is 2, 3, 4, then P intersect Q is described as, well, first of all, what is P intersect Q? Not P intersect Q, sorry, P union Q. You see how I get mistake? U, right? The horseshoe is like a U, so it's a union. So P union Q. That is everything in P and everything in Q. You do not repeat the elements. So it'll be 2, 3, 4, 5, and 6. So let's see what are the options here now, right? The set P intersect Q could be described as numbers, the set of numbers such that those numbers are between 1 and 7. They include 1, but they do not include 7. Well, this doesn't include 1. So we have numbers between, so part B is not part A. Part B, we have numbers between 1 and 7, but they don't include 1 or 7. That looks like it. So part B definitely looks like numbers between 1 and 7, not including 1 and 7, and of course they are natural numbers, right? Part C, numbers between 2 and 6, but they include 2, yes, but they don't include 6. Well, we have 6, so it's not part C. And part D, you can see numbers between 2 and 6, not including 2 and 6. Well, we have 2 and 6 there, so it's not D. So we get B. Which of the following sets is defined by that? Well, first of all, what is that? All right, the set of numbers that are elements of integers. Integers, and I think we did the sets of numbers already. An integer includes negative numbers. So it is the set of integers such that those numbers are between -1 and 3, but they include the -1, but they do not include the 3. So that would be -1, 0, 1, 2, and you're not including 3. So -1, 0, 1, 2, that's part C. If the universal set U is 1, 2, 3, 4, 5, 6, and H is 3, 4, 6, then H complement. You had to know that that means complement. So if H is 3, 4, and 6, then H complement will be everything that is not in H. So if this is the universal set, and H is 3, 4, and 6, and then the rest of them is 1, 2, and 5, you know, the H complement is everything outside of H, which is 1, 2, and 5, which is D. All the students in our class play Scrabble or checkers or both. Same question again, right? They didn't give you a total this time though, but look at what they do instead. They say if 36%, so the minute they use percent, you know the total had to be 100%. All the students would be 100%. That's not. Well, let me see if I'm correct on that. If 36% of the students play Scrabble only, and 48% of the students play checkers only, what percentage of the students play both? So I have here, and this is like the same question, but the other way around, you could say, right? This is Scrabble. This is chess. 36% of the students play Scrabble only. So Scrabble only, that is here, 36%, right? 48% of the students play checkers only. So that is 48% will go here. So obviously in the middle will be the 100% minus these two. So what percentage of students play both the games? Well, in the middle here, I will have the total students, 100%, minus these 36 plus 48. So let me see what that's gonna be. 36 plus 48 is 84. So that's 100 minus 84. Is 16. So 16% of students play both games. So the Venn diagram below shows the number of students in Form 5A who have visited Canada or Dominica, right? So as seen here, it have 3 students who visited Canada only. It have 10 students who visited Dominica only. It have X amount of students who visited both of them. and it have 2x amount of students who didn't visit none. How many students have visited Dominica only? 10 students. Yay, Agama. Write an expression. An expression does not have an equal sign in terms of x to represent the total number of students who have visited Canada. So Canada is 3 plus x. That's it. Part 3. Given that there are 25 students in total, calculate the value of x. So it have 25 students in total. So that means that the 3 plus the x plus the 10 plus the 2x, the 2x on the outside, that does make up for all of the students. So that is your 25 students, right? So I could see x plus 2x is 3x, and then 3 plus 10 is 13. And so 3x is 25 minus 13, which is 12. And so x will be 12 divided by 3. So x will be 4. And so you can immediately see that there will be 4 students here who visited both Canada and Dominica, and the amount of students who visited none would be 2 multiplied by 4, which is 8 students over here. So given that there are 25 students in the form, calculate the value of x. This is the calculation. X is equal to 4. Hence, write down the number of students in each of the following subsets. So we have the subset C union D. And we can see that C union D have 3 students plus the 4 students plus the 10 students. That is C union D. Everything inside of these 2 circles here. So 3 plus 4 plus 10 is 17, I believe. Tell me if I do that wrong. You know, the easier the question, the easier it is to make a mistake, right? C intersect D, which is this one here, we can see that is X, which is 4. Right? And then we have C union D brackets all complement. And remember, C union D brackets all complements means that if I have C and D, this is C union D, I want everything outside of C union D, right? So what is outside of C union D? Just that, 2x, which is 2 times 4, which is 8. Describe, using set notation only, the shaded regions in each Venn diagram below. So I have 4 Venn diagrams here. The first one is done for you. So you can see this first one here. We have the set A, we have the set B, and the shaded part is A intersect B. And so that is what they have in set notation here, A intersect B. This one here includes all of A and all of B. So this will be A union B. This one is it have everything, imagine everything in A and everything in B, but everything outside of A union B. So imagine if I take A union B, which is everything in A and everything in B, but then I go brackets the complement, everything outside of that. This is what we will get here. And then this here is just simply the set A. The following information is given. U is that universal set. It looks like numbers from 1 to 10. P is prime numbers. Q is odd numbers, right? Draw a Venn diagram to represent the information above. So, the universal set will look like this. And the odd numbers and the prime numbers will intersect. So I will have the prime numbers here, and I know that there will be an intersection with the odd numbers. And I know there'll be a big intersection because, oh no, that's Q, right? Because a lot of the prime numbers are odd, yeah? So from 1 to 10, well, 1 is not a prime, so 1 is odd, right? 2 is the first prime, but 2 is not odd. So 2 is not going to be inside of here at all, right? 3 is prime and odd. 4 is neither prime nor odd. 5 is prime and odd. 6 is neither. 7 is both prime and odd. 8 is neither. 9 is an odd number, but it's not prime. And 10 is an even number, so it's not either. And this is what the Venn diagram would look like, with 3, 5, and 7 being both prime and odd. Let me see, anybody, if anybody could let me know if I make any mistakes here. I don't think I did. And I'll leave that there while you're writing it down. The Venn diagram shows the number of elements in each region. So this Venn diagram here is a different thing. The Venn diagram shows the number of elements in each region. So I see in here a Venn diagram. Determine how many elements are in each of the following sets. A intersect B. So A intersect B is this one here. So that will be 4. No, you see, nobody correct me. Nobody correct me. Nobody correct me. You see that? You see that? I wonder if I just teaching to myself right now. I seeing how I call it nobody name and thing. Yeah, not today. But this is a U. So this is union. So A union B, I'm so sorry. A union B is actually all of this. So it'll be 10 plus 4 is 14, 15, 16, 17. So that is 17 in A union B. This is the intersect. It looks like an N. So intersect N union U, right? So A intersect B, that is just the 4 there. You have A intersect B complement. So check this out. This is A intersect B. And I want the complement, which is everything outside of that. That is what I want. Everything outside. So that would be the 10 plus the 3 plus the 8. No 4, right? So 18, 19, 20, 21. And then the universal set will have everybody. So 10 and 8 is 18, 19, 20, and 5 I think is 25. Let me know if I count that correct. I'm going to just add it here. 10 plus 4 plus 3 plus 8 is 25. Yes? The universal set U is defined as the set of integers between 11 and 26. Right? That is interesting. So U is the set of integers between 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 26. All right. That is the set U. Cool. A and B are subsets of U such that A is even numbers and B are multiples of 3. All right. First of all, how many members or elements are there in the universal set? Well, it's a good thing I wrote them out because I actually had to come and count them. And I mean, I could just go 26 minus 11, I guess. 15, but let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you see, it's a good thing I count. So 16 elements. Right? List the members of subset A. So subset A is the set of even numbers. So that will be 12, 14, 16, 18, 20, 22, 24, 26. That is my even numbers. List the members of the subset B. So that is multiples. So you see, Michelle, now we're talking about multiples. These are the numbers that are bigger than 3, right? Multiples of 3 are 12. Wait this boy. 3 to 3 to 9, 4 trees are 12, 5 trees are 15, 6 trees are 18, 7 trees are 21, 8 trees are 24, 9 trees are 27. So we're outside of the universe there. Right? Draw a Venn diagram to represent the relationships between all of them. So the Venn diagram, you'll have your universal set. U. And let's see. We have the set A and the set B, and do the set A and B intersect? Because I want to know if to draw it like this or if to draw it intersecting like this. That is what I want to know. So first of all, I have to decide, are they intersecting at all? Right? So I see in here that yes, they do intersect. Both of them have 12. Both of them have 18. Both of them have 24. So that's 3 numbers in the intersection there. Right, so that means that I'm gonna have set A over here, and then I'll have set B over here, and I will have them intersecting. This is A, this is B. In fact, I should draw it a little better than that simply because we are dealing with a lot of numbers here. It's 15 numbers, so let me draw it a little bit better. That is your set A. That is the set B. So we have the set A and the set B. And the intersection here will have 12, 18, and 24. In A only, I'll have 14, 16, 20, 22, 26. In B only, I'll have 15 and 21. But remember, we have all of the other numbers that are not in A or B. So that would be 11, 13, 14 is the even numbers, multiples of 3. 15, 16, 17. I guess the primes will be outside, right? 18 is there. 19 is outside. 20 is there. 21, 22, 23 will be outside. 24 is there. 25 will be outside. 26 is there. And this is what the Venn diagram will look like. I see this whole thing as part 1 here. In a survey of 36 students, it was found that 30 play tennis, X display volleyball only, and you notice I have a Venn diagram here that kind of have this information in it. It has some of the information, but it don't have all, right? 30 display tennis, so tennis is 30 in all, right? X display volleyball only, I'm seeing that here, X for volleyball only in this section. 9X play both tennis and volleyball, all right? 4 play neither tennis nor volleyball. So 4 display neither tennis nor volleyball, but I'm seeing a Z over here. So I don't know if that could be 4, right? So we see in here, V is the students who play volleyball, T is the students who play tennis. Copy and complete the Venn diagram below and show the number of students in the subsets marked Y and Z. Show the number of students in Y and Z. So 4 play neither tennis nor volleyball. So that would be here. So Z is 4. And Y is the people who play tennis only. So the people who play tennis only, 30 play tennis, 9X play both tennis and volleyball. So 30 display tennis, that is the total. So this total here is 30, right? The amount here in Y is the total amount 30 minus the amount that play in volleyball as well, 9X. So Z is 4, Y is 30 minus 9X. Interesting. Write an expression in X to represent the total number of students in the survey. So the total number of students in the survey is 36 students. So, but they say an expression, they didn't say equation. So you see an expression and an equation, right? So the expression in X representing the total number of students in the survey, well, that is this amount X, and I'll just write it on the side here actually. So number 2, part A, is X plus you have the 9X plus you have the Y plus you have the Z, which is 4. And you know, I would have put equal 36 because there's 36 students in all. Yeah, I would have put equal 36, but they didn't ask for an equation. They asked for an expression. And they asked for an expression in x. So what is y doing there? I'll have to definitely simplify that. So that would imply x plus 9x plus y, which is 30 minus 9x plus 4. So you can see 9x will cancel with this 9x. And so I'll have 30 plus 4, which is x plus 34. Right? So an expression in x to represent the total number of students in the survey is x plus 34. That is the expression. Now they're going to ask for an equation. Write an equation in x to represent the total number of students in the survey. So this is the total, the expression for the total amount, x plus 34, and then the equation is where I will equate it to the total number 36. So you see the difference between the expression and the equation. I could have, over here, I could have put 36 and solved for x one time. But they didn't ask for that. They asked for the expression, not the equation. Alright, so this is the equation, and we can see here x is going to be 36 minus 34, which is 2. The incomplete Venn diagram below shows the number of students in a class of 28 who play football and tennis. So there's an incomplete Venn diagram, right? U is the all students in the class, F is the total who play football, T is the total who play tennis. All right. And additional information about the class is that 12 students play tennis. So tennis is 12. All right, so that's this total amount here. That means that this amount inside of here will be 12, which is the total amount of students that play in tennis, minus x, which is the students that play in football as well. So 12 minus x will be those students that play in tennis only, right? 15 students play in football, right? So we have 15 students here. And that means that the students who play in football only will be 15 minus x, right? 8 students play neither football nor tennis. So no football, no tennis. 8 students will be on the outside here, right? X students play both football and tennis. Well, that is already there. Complete the Venn diagram above to represent the information showing the numbers of each student in each subset. So this is the numbers of each student in each subset. So the subset of football only is this. The subset of football and tennis is this. The subset of tennis only is this. And the subset of neither of them will be this. Calculate the value of x. Was that the whole question? Wow, that was an easy question. I guess this was just a part. This is just 3 marks. This is like a part B of a question. Right? So calculate the value of x. Did they give us the total amount? A class of 28, right? So it's 28 here. Right? So students in a class of 28. So that means that this plus this plus this plus this will give me 28. Now you can easily see, I don't even have to go 28 because I could see that, well, 8 students on the outside. That means that these guys on the inside will add up to 20. So I could have do everybody equals 28, but I will just do these 3 here equals 20. So 15 minus x plus x plus the 12 minus x. And those three alone will give me 20 students plus the 8 outside to give me the 28. Yeah. So it's 20 students who are actually playing sports here. And so I could see that this x and this x gone. I'll have 15 plus 12 is 27. Minus x is 20. I throw this x across, I throw this 20 here. So x will be 27 minus 20. X is 7.